Hey, good afternoon or good morning, wherever you guys are at, or good evening. This is Raul with Anant Corporation, and we're going to kick off the first recorded Cassandra Lunch. We've been doing this for a couple of months now. This is a group event that we have as an extension to our Cassandra in-person meetup and the VC in-person meetup, which obviously during the time of COVID, we're not able to do. So if you see this video on YouTube, share the video. Also, we'll have links to the meetup where you can share that for future events. And if you have a desire to present something here, if it's related to Cassandra or any other related technologies, please reach out to me or one of the other co-organizers, which are Akwi and myself. You can reach out to us via email. Our email is on the screen. And we'll be also linking a contact form in the YouTube comments. If you'd like to co-organize and work on Cassandra Lunch beyond DC and Chicago, I'd love to be able to do this across different cities. Really want to make this a long-lasting virtual event for Cassandra users and developers and administrators from around the world. We are incubating this group as part of Data Community DC. We're an inclusive group with people from all backgrounds, gender, sexual orientation, religion. If you are underrepresented community, we'd love to have you present. We'll prioritize you over other people, just because we know that it's hard to get into technology, especially high tech. We are part of a much larger consortium of meetup groups. That's what Data Community DC is. It's a nonprofit, and we cover everything from data innovation, which is a lot about business intelligence for business innovation, data science DC, statistics, data visualization, and there's even a group that gets together at night to co-work around data. It's called Night Owls. We cover everything related to Cassandra, which nowadays, because Cassandra is at the heart of many data platforms, it can also deal with working with Spark or Flink or with Kafka, and even variants of Cassandra such as Alessandra, Datastacks, Yugabytes, and Skilla. Love to see presentations on related technologies, even Cosmos DB or managed key spaces by Amazon. Normally during an in-person meeting, we all get up and introduce ourselves. Today, I don't see any new participants today. Otherwise, we'd ask for their introductions. Go forward. Rules of the game are, if somebody's presenting, you can go ahead and ask the question politely. If you have something to add to the conversation, just interject politely and raise your hand in the participants chat and you can add a comment. Datastacks is one of our sponsors. They have in the past provided us event venues and also help co-market this on their workshops. We are also sponsored by GW Business Analytics Group. They provide us a venue on site at GW, and they have been for a while. We have some sponsors in DC and in Chicago. If you'd like to sponsor us, right now, really, we don't have any costs because we're doing everything over Zoom, but we anticipate as we get back to the in-person meetings, we'll love to get some sponsors for pizza or venues or whatever you can provide. Our institutional sponsors actually promote, they sponsor all Data Community DC as a nonprofit, and they allow us to make the shortfall for event costs when we don't have sponsors. Right now, we're okay. Normally we do announcements. Does anybody have an announcement for an upcoming meetup, hackathon, conference, or class? All right, I'll go ahead and mention that there's a talk coming up from our company on Presto and Cassandra. If you go to anant.us and then click on events, you'll see the next coming events. Datastacks is also doing a tremendously good job of an 8-week series, an 8-week workshop, which they have 2 live sessions a week, but you can still catch up if you sign up for that now. Always welcome to this call and the Datastacks weekly workshops. If you have something to add to the community, please let us know, and we can put that up here to promote your weekly event if you have one. So today I was thinking of talking about the newer features that are coming out in Cassandra 4.0. We have talked about the evolution of Cassandra over the last 10 or so years. There's been a lot of changes since the first version of Cassandra, which Facebook released, and then the second or so version that people from Rackspace and at that point Riptana and then Datastacks released. And now what we're seeing is, because so many people use Cassandra, there's some features that people have been asking for that have been put into the product because of a lot of user demand. So Cassandra 4.0 started to get a lot more attention last year when Datastacks brought back their conference. Nate McCall from Apache Cassandra is the project chair. He talked about some of the major features that Cassandra would have. And this is a high-level summary. We're also going to go into the release documentation to see what's coming up. One of the main things that people gripe about Cassandra is the time it takes to repair data. Repair means that because there's different copies of the data for resiliency, sometimes the data gets out of sync. And repair just means to reconcile everything. People think that it means to repair bad data. Well, technically it's not bad data. There's always a good version of the data if you use the right consistency level. It's just making sure that all the copies are then reflecting that good copy. They're making improvements based on just how the data is being broken up and then sent. There's also a rewrite of the messaging engine. The messaging engine is what makes all the different nodes in Cassandra work together. Cassandra uses something called a staged event-driven architecture called SETA. And SETA is essentially a system that you can use in any software where you have different processes that are different parts of different stages of a larger process, and they send events between each other. What people talk about microservices and using RabbitMQ, Redis, et cetera, or Kafka, essentially is staged event architecture, event-driven architecture. And now, when people build large platforms, they're making staged event-driven architecture, but across various services built on different platforms and programs. In Cassandra, all that is in one machine. There's 16 quote-unquote microservices or stages, and each machine then has those 16 processes running, and they just send messages back and forth. So when you request data, it's going to the read request stage, which then says, I have to find information, and then it goes to the next stage and finds information, and then it eventually responds back. Same thing with the write. So if you look for, let's say, SETA architecture Cassandra, right? The messaging service sends a message to the read stage. Read stage may say, I don't have this information. Go to a different node. The different node says, I have the data. It'll request the data, and it'll then send it back, eventually back to the client requesting node or the coordinator node. So improving messaging makes all of this work faster. It's kind of like, using RabbitMQ And as your system gets bigger and bigger and bigger, RabbitMQ is a choke point, so you decide to use Kafka. Well, in this case, the optimization for Cassandra is really on how much data is being moved back and forth. It's also using a different communication engine called Netty. And Netty's been around for a while, but it just moving from Java's native I/O messaging to Netty will make it faster. There's an idea of something called zero copy support, which determines how much information needs to be moved from one machine to the other. And I'm not going to get into that today, but it allows us to move bigger SS tables between nodes, which then helps us have better containerized Cassandra on Kubernetes. Because when we need to expand the cluster, SS tables need to be copied. When you consolidate the cluster, SS tables need to be then consolidated back. So it's fundamentally, if you think about all of these changes, it's knocking away at making Cassandra better, faster, more stronger, making it stronger. The other thing over the last year I've noticed is that there are a few tools that are out there that help manage Cassandra better. And initially there weren't any official ways to interact except via what's called the JMX, Java Management Extensions. Now there's a better method. So there are a few sidecars out there today. So there's one called Medusa, which is for backing up. And there's another one called Reaper, which is for repair. And Datastacks actually released one for metrics collection, and they have another management API as a sidecar. So a sidecar just means that you have Cassandra, you don't need the sidecars, but then you can have the sidecars to enhance it. Or you can make your own sidecars. Just depends on what the goal is. And sidecars are a common pattern in server software, so that you can have resilient software that is lightweight when you need it, or you can add the features as you want after the fact. And sidecars in the world of containers around Cassandra, it makes perfect sense, right? You can bring up a sidecar, do something, and take it away. Going to Java 11 will make Java more efficient. It will be more efficient because it introduces a new garbage collection engine called Z Garbage Collection, and we'll see what it has to offer. But Java 11, as you can see, I mean, Java 8 was the oldest version that was being supported. Now there's 9.10. Now we have to basically use the newest version of Java. There are better, diagnostic events and logging, just so that, for like auditing purposes or for diagnostic purposes, there's just better tooling in there, and we'll get into what that is. And another thing is, there was a call to have more community events. So this is a community event where we're actually helping out with that. Going into the features on the release list, as you can see, there's a lot of big changes coming in. Support for Java 11, basically, this just explains how to build it, but we're not going to get into, for example, the benefits of Java 8 and 11. You can go into the Java site and find that out. Virtual tables are not, initially when I read about virtual tables, I did not know what they were, and I thought it was basically to virtualize outside data, but that's not what this is about. This is about making data that's in Cassandra or the configuration available via a table interface. So specifically is to expose metrics that are in JMX, or like what you ask for via Node Tool, or what you'd get via Ops Center if you have Datastacks. It's to basically get that via CQL. So we have an open source tool that we use for table analysis. We get data from Node tool, we then pivot it, and we take the CSV and we make it into an Excel that's conditionally formatted. Now we can just pull it directly from Cassandra as a table, essentially, and not have to go through that process. But obviously, for our purposes, for backwards compatibility, we're going to still have the Node tool interface. The other thing that could be seen is the YAML configuration, the Cassandra YAML configuration that is loaded into memory to run Cassandra. Normally, that's only retrieved via Node tool commands, or you can be set via Node tool commands after the system is up and running. Now you can see that information directly in Cassandra. A lot of limitations, right? You can't alter or delete tables exposing primarily read. I believe can set the settings without having to use the Node tool command. But I have to double check that. But anything that you get in the tool, you can get via table. So, who are the clients that are connected to the cluster? Here's another useful one. What are the thread pools? So normally we run TP stats. We can get all the threads that are running. This is, by the way, the listing of the different stages of Cassandra. Remember we talked about Cassandra earlier? These are now what? So 5, 20, 25, 30, sorry, 20, I believe that's 25 stages. All right. Audit logging, it's big when we have an enterprise environment where every user's activity needs to be audited, so that if a major failure happens, you can understand exactly who did it. Or if it's a bug, you can turn on auditing and understand what's happening to step by step what the program is doing. Now, CQL supports a lot of different commands. Auditing means that it would basically audit every command that is being sent to Cassandra, every select statement, every delete statement. So it just depends on what we need it for. It doesn't have to be on all of the key spaces or tables. You can just do it on some of them. You can also say I just want to know when somebody's doing a delete statement. I just want to know when somebody's doing a truncate statement. Okay. The different categories, right? Errors, queries, very useful. The full query logging is where it has the biggest power. A full query logging means that the full request with exactly the inputs and outputs, what where clauses, etc. Normally that's available via trace. Like you would be able to get the full query log and see exactly what's happening, one statement at a time. And if you look at the output, it's, what is it? Single query. When did it start? SQL protocol. How long did it take afterwards? And then, what was the actual query? And during a performance test, we could take this and parse it and say, okay, well, these type of queries are taking longer. These type of queries are fast. It just helps us complete the circle of knowing how the system is performing and how it can be, how it can be improved. As I messaged earlier, internally it used to use Java native communications. Now it would be using Netty, and it's the protocol itself comes down to what is the verb, what parameters, how many parameters are we sending, what is the data, and then the payload size and the payload if there's a response. So generally, this type of messaging is very esoteric in that, you know, normally most people don't ever need to know what's happening under the hood here. But if you're curious, using the virtual tables, you can see like what's the size of the message, what type of message it was. Streaming is basically what is used to repair SS tables. When a machine goes down, we bring up a new one. When we're moving token ranges, when we're bootstrapping a brand new node, when we're rebuilding a cluster, or when we're expanding a cluster, or contracting a cluster. So when we do streaming based on Netty, we get this generally, you know, better performance. Another big reason for that performance boost is because it's asynchronous. Everything is going to be done via asynchronous from the synchronous calls, which is a blocking call. That just automatically makes things faster. The other is that because more connections can be open. The other is this idea of a zero copy streaming, which I was mentioning earlier. Essentially, you know, it makes the SS tables into objects. It takes exactly what needs to be moved over and sends it over this thing called zero copy API. And it basically goes through and improves the throughput. And you know, again, I haven't used it, so I have to see what this looks like. Its main, you know, limitations is going to be basically network and disk I/O, because it's, you know, supersized. Looks like their benchmark says that it's 5 times faster, based on the old way of streaming, which was to take a full partition and move it over. So that's worth a try to take a look at. Let's see. Transient replication is another really interesting feature, which I was thinking about the other day, actually, why this is important. Normally, when you have a key space, you have, you know, 3 copies of it, 3 replicas of it, and you do quorum calls, meaning if there's 3 replicas, you have to make sure that it has 2 data points before it sets the half data, or if you say consistency level 1, it'll only check one of those replicas. Transient replication allows you to have your main replicas, let's say 3, and then a transient replica, meaning 1. So the full replicas are the ones that are responsible for the data. The transient replica is for storing unrepaired data for the same token ranges. So it allows us to have copies of data that are useful for us for speed. So we can have what's called a, sorry, there's a mosquito here. So we can have these things called cheap quorums, meaning the data is replicated and it's copied to more machines. And because it's copied to more machines, it allows us to read it much, much faster without it having to be an authoritative copy. So for example, you know, I may only want 3 authoritative replicas, but I may want 5 transient replicas, because we have a lot, like, you know, 10 times as much read traffic on something than write traffic. I'm speculating, but that would be one of the use cases I would use it for. There's a lot of stuff you can't use transient replicas for. So like if you have, you know, secondary indices, materialized views, it doesn't support like log batches, lightweight transactions. It's really for this idea of a cheap quorum, meaning being able to quickly get data from various replicas. And, you know, it's not supposed to be consistent. It's not meant for strong consistency. Right? They're just meant for serving reads faster. Read repairs don't repair transient replica, right? Let's see. So again, I haven't tried it out, but this seems promising for high availability, high traffic applications that really want to squeeze as much of the power of Cassandra for reads. That's the overview of Cassandra for features. The reason I wanted to bring this up is that 4.0 beta 1 is coming out soon. If I recall correctly, seems like I saw this the other day on the 4.0 beta 1, and then I think that's being released, but then 4.0 beta 5 is in development right now. So we're really getting close to 4.0, which means everybody's going to have to think about upgrades and moving to it. Any questions from you guys about 4.0? No. All right. Great. Any questions about Cassandra in general, what you guys have been working on that you'd like to discuss? Anything that anybody wants to show off? All right. Actually, Arpan, do you want to give a quick preview of what you're working on with Presto, I believe?
Yeah, so Presto is an open source SQL query engine. So it's not a database, it's a query engine. And we're looking into learning it as well as how to connect it with Cassandra. And I've seen videos and I've learned how to do it locally on a local 127.0.0.1 contact point. But now I'm trying to see if we can use Datastacks as Astra, which is Cassandra in the cloud, if you're not familiar with it. So that way you don't have to go through the trouble of installing Cassandra, creating new users, running new key spaces locally, where you can do everything in the cloud. So I've looked into it. So Astra uses something called a Secure Connect bundle. So if you're using one of their drivers and you're connecting to your Astra instance programmatically, you can just use it with the client option of Secure Connect bundle. But I'm looking into, say, using Presto, just like on your CLI, and seeing if using their config file. So when you're setting up a Cassandra config file, you name your Cassandra contact points, and you also name, if your port isn't defaulted to 9042, you would need to state it. So I'm looking at essentially how to connect Presto locally at this time to Astra, which is Cassandra in the cloud. So if I can find out and if I can get that to work, ideally it would be able to save people time and resources to having from downloading Cassandra, running everything locally, pushing to production on their own servers, whereas Datastacks also already handles serving it in the cloud, or if you want to pay for an account using AWS or GCP. But all the demo that I'm trying to do would be on the free tier, which is a 10 gig free database. So if I can get it to work, hopefully people can try it out and learn Presto and use it with Cassandra.
Cool. Very cool. Awesome. Looking forward to that. Yeah, if you guys can see my screen, just want to verify because the little Zoom thing that goes around is no longer showing for me.
Yeah, I can see it.
Okay.
Yeah, I can still see it.
Yeah, so Presto is also a product of Facebook, which has been open sourced. It gives us the ability to kind of do what Spark SQL would allow us to do, but without necessarily using without necessarily using a separate Spark cluster. You just have a Presto cluster that doesn't really store any data. It's just doing reads. The other thing that's interesting is that Presto has a Spark runner. So technically you can run Presto on Spark. So that would be interesting to see if that makes Presto faster because it's parallelized via Spark rather than its own internal kind of data parallelization. But yeah, it's overall Presto. It's not just limited to Cassandra; it can work with other databases. So looking forward to that talk. And another one that I'm working on is to Git podify the Cassandra real-time code, which I just made public. If it wasn't out there earlier, but Obi, you've given a presentation on this before. But I'm Git podifying it in the sense that anybody will be able to just run the demo on Gitpod, meaning run Kafka, run Cassandra, run the Python code to put messages into Kafka, and then have the Spark job pull it from Kafka and put it into Cassandra. And this is part of an ongoing series called Event-Driven Toolkit. This is the second major talk. The first major talk was about making an API using Python and Node. This will be an add-on to that. But in the meantime, I may have mentioned this to you last week. I'm going to mention it to you again because I thought it was really cool. If you go to datastacks.com/dev, you can run through some pretty interesting use cases without even going into Gitpod. So, like just try out Cassandra CQL, or I don't see here, but there was one, using the Kafka connector, or using Cassandra Kubernetes. So it's really rich. This tool they call Kata Coda to learn the basics. But when you start really getting into it, you need something like Gitpod, and Gitpod allows us to have a full IDE in a virtual environment on a browser. So, anyways, that's just a couple of previews coming up for the next time. If you have again any ideas for talks, please reach out to us. We're going to be planning out the next, I would say, 20 weeks, which will get us to the end of the year, with some holiday weeks. So eager to put you on the docket. Thanks everybody for joining, and we will see you next time. Take it easy, guys.